Good morning, friends. Today we will start from that the grounding and that the shielding for that the in that the lecture. Here the in practice the many instrument system for used the low level signals measurement are in that the environment the containing many source such as the electrical and magnetic which produce the undesirable signal along with the wanted signal called as that the noise or interference. What that is the unwanted electrical noise signal called as that the parasitic voltage due to the power line of that the voltage is coupled in the wanted signal produces in that the measurement system. In this the way external as well as the internal source coupled the noise in that the signal, but the effect of that the external noise signal is more serious. Thus the electronic measuring system are sensitive to noise and that the need to design carefully. The technique used to eliminate noise effect guarding technique are used. These are the grounding and that the shielding techniques classified as the capacitive noise, inductive noise, or that the electromagnetic, or that the conductivity coupled noise, or that the ground loop noise. When conductor carries current, then the magnetic field is exit around. When the conductor possesses often the electrical charge, then and the electrical field exists around it. This field magnetic and that the electric varies from that with respect to change in that the current and that the charge the conductor. These fields are called as that the induction field or near the field. The capacitive and inductive interference are due to such as the induction field. The radiation electromagnetic wave, that means the EM wave, induces the AC voltage of their the frequency same frequency in that the conductor when the waves crosses for that the conductor. This induced for that the AC signals are called that the electromagnetic interference or that the radiated interference. The region where electrical and magnetic field becomes negligible and their radiated EM wave takes over the called far field. The ground loop interference can be generated due to the near field effects as well as the far field effects and some electrical phenomenon as well as. These interference, noise and their eliminating methods are discussed followed by that the capacitive noise or that the electrostatic shielding. When the two conductors are near to each other, they form capacitive effect and get electrically coupled to each other. Thus the voltage change in that the one conductor affects the voltage change in that the other conductor. So the low level signal carrying conductor and that the low level signal transduce affect by that the capacitive effect. The interference due to the capacitive effect is called that the capacitive interference or that the electrically coupled interference. The capacitive interference causes generate that the parasitic voltage. In that figure shows the conductor 1 is that the low level signal conductor and conductor 2 is that the signal conductor. Consider the conductor 1 is connected to that the ground by the resistor R and that the both ends, and the conductor 2 is that the carrying AC signal of that the amplitude VM. This coupling capacitor CC value can calculated by the know of that the magnitude of the induced capacitor signal, and that the R2 is that the equivalent resistor and amplitude and frequency of that the AC signal. The Unreasonable capacitive pickup is directly proportional to that the first one input impedance of that the instrument, second one capacitive between that the interfering source and test leads, third one voltage between the interfering source and test leads, and fourth one is that the frequency of that the voltage of that the interfering source. In that the very common method, the avoiding for that the capacitive effect is to the electrostatic shield. Two wires carrying the low level signals, and this shield is that the metal enclosed with that the surrounding low level signals source, and that the sleeves which is surrounded two test leads. Such a shielding method are very effective in that the avoiding the capacitive effective as well as the external field shield. In that the shielding, while the using such as the shield, care must be taken that the signal source is grounded at one end, and the shield must be grounded at the signal source grounded point. Thus the shield remains almost the zero potential and cannot pick up any other noise signal through the large coupling capacitor is present between that the low level signal conductor and that the shield itself. This shown for that the figure in that the shielding to avoid the capacitive interference. Then second one is that the electromagnetic shielding. The energy associated with that the current or that the change in the variation for that the frequency of that the high frequency, such a radiation are from that the electromagnetic waves, and its frequency is comparable with that the ratio frequency waves. Such a wave may be the signal from that the radio or that the radar transmitter, or that the generated by that the some other source. This EM waves causes the noise in that the measuring system. The noise caused due to the EM waves is called as that the EM noise. Therefore, all the sensitive circuits from that the measurement system must be protected from that the RF waves. Whereas the sources of that the electromagnetic interference is that the gas discharges in that the fluorescent light, sparking of that the electrical switches relays, or that the arching of that the electrical motors and generator. Here that the high frequency oscillation and that the pulse circuit, the signals from that the TV, radar and that the radio transmitter. The interference due to as that the electromagnetic waves are comparable with that the capacitive and that the inductive interference. As the frequency increases, both the interference are increases. So this interference may be the causes of that the capacitive and inductive interference also. The electromagnetic waves have the two components as electrical and magnetic, and that the EM wave get the halved with one of the two components eliminated. The shield as the eliminated for that the electrostatic interference, that electrical component. So the once electrical component get eliminated with the help of that the shield, and the magnetic component also get terminated, and that the EM wave is that the terminator for that the permanently. In this way of that the EM waves get that the vanished. The next one for that the grounding concept. The body of that the electrical measuring equipment should be have that the grounded from that the electrical safety. Such a ground connection achieved using for that the one or more rod, copper or that the iron are burned into the earth at that the depth of that the 10 to 100 feet below. In this grounding is not proper, then there may be the possibility of that the leakage and the hence defect in that the measuring instrument. Their voltage between that the body and equipment, the ground measuring instrument produce voltage between that the equipment and that the ground, this voltage should not more than the 42 volt good working of that the equipment. So the defective grounding in that the various measurement equipment has the presence of that the ground current is called that the ground loops. This ground loop is closed electrical path between that the ground wire and that the measuring system ground plane. As shown in that the figure, these ground loops are created when the ground conductor of that the system is connected to that the ground plane at that the different points. Consider the example for that the measuring system as shown in that the figure number 8, which is clearly illustrate for that the formation of that the ground loop and that the ground loop and ground current. The resistance of that the R1 and R2 are their cable resistance, and then the transducer is connected to that the ground and that the measuring instrument. There exists a small voltage ECM between the 2 points when the transducer and instrument are at the ground, and this due to the soil sensitivity and that the ground loop is current. This ECM is called that the virtual voltage source. These grounds wires of that the transducer and that the instrument have that the low impedance path with respect to that the ground. Thus ground loop hole has that the low impedance path, therefore the very small voltage can be produced the large ground loop currents which flows through that the measuring system. There are the two causes of that the ground loop currents. First one is that the difference between that the points and that the ground, whereas the terminals are connected, and that the due to the stay magnetic field and that the radio frequency waves which can be the inductively picked up. There are the various technique to reduces the ground loop interference signals, and these are the single point grounding. The second one is that the use of that the differential input amplifier. The third one is that the input guarding, and fourth one is that the use of doubly shielded cable. In that the first one, single point grounding, this method was used for that the earlier days when the differential amplifier is not available. This method is based on that the factor current cannot be established unless and that the closed loop path is at the available. Here, if the ground loop formation itself instigated, the ground loop current cannot flow and that the eliminates the ground loop interference. The best method is that the no effective ground path exists in that the complete system. The second one is that the use of that the differential input amplifier. The ground loop interference and that the common mode voltage interference can be eliminated or that the reduced by using the differential input amplifier. In that the differential gain AD and CMRR, the differential amplifier is very large. Now that the Vs is that the input voltage and that the ECM is that the common mode voltage at that the both inputs of that the differential amplifier. Then third for that the input guarding. In this method, the complete measuring or that the input circuit unit of that the differential amplifier is placed inside and that the metallic guard. This shield of that the metal used for that the purpose called as that the guard shield, and this guard shield is illustrated using for that the isolating device like as the isolation transformer or that the optoelectrical isolator. Such an entire assembly, that is the guard shield amplifier with that the isolation device, is called that the isolation amplifier. Then next for that the use of that the doubly shielded cable. If the AC signal is to be measured, then the floating shield and that the guard shield are not used. Then the doubly shielded cables techniques is used. The figure shows for that the working of that the doubly shielded cable techniques. The used for that the doubly shielded The inner shield is that the floating shield. Here the floating shield of a doubly shielded cable is that the brought about same the potential voltage Vs to be measured. The coupling capacitor C1 is made up from that the ineffective, no current flows through it, and the coupling capacitor C2 is that the effective but current through that the complete path with that the without RS. This is possible for that the current I is delivered input amplifier while Vy is that the output A. This is the input amplifier through for that the series mode voltage.